All right, so we're going to continue today with quadratics and moving into quadratic characteristics. So we're going to be looking at all the characteristics that the quadratic has. We already have done two of them. That's the roots, the x-intercepts. We're going to be looking at the symmetry around the central line called the axis of symmetry and the vertex, the y-intercept. So when we graph today, we're going to be looking at 5 different things, okay? 5 different points or characteristics of the quadratic. So we're not going to just do the 2 points and then a quick sketch. We're actually going to have a much more accurate graph today. Okay, so I want you to make sure that you open this graphic organizer today and have it open with your work, because this is where all the formulas are, okay? And all the important parts of our quadratic. So if we take a look at our picture over here, we see that we have our quadratic, and we already know that we have our 2 roots or x-intercepts. Those we've already dealt with. So we've already dealt with these 2, okay? So these are not new. We've touched on the y-intercept, okay, in one problem earlier this week, and we've also touched on the axis of symmetry. So the axis of symmetry is what rolls down the middle of the parabola. Okay, notice it's a dashed line because it's kind of an invisible line, and it is the middle of the parabola. Okay, and then the new one for us today is the vertex, which is going to control whether it's a maximum or a minimum. So we've got lots of new formulas today, but the most complex one we've already learned because that was the quadratic formula. The rest of these are not a big deal. They actually use pieces of the quadratic formula. So let's take a look at our vertex. So the vertex is negative b over 2a comma negative b squared over 4a plus c. So that is an ordered pair. The intercept is just 0c. That one's probably the easiest one to find. Okay, now the axis of symmetry, that one is negative b over 2a. So it's actually the x value of our vertex. Okay, it's actually the x value of the vertex, because when we think about our axis of symmetry, it runs through the middle of our parabola, which means it has to run through the vertex. Okay, now the other new things that we're going to be talking about today are maximum and minimum, which we've kind of been talking about, because we've said if a is positive, it's going to be a smile, and if a is positive, it's going to be negative, it's going to be a frown. So if it is a minimum, then a is positive, it's going to be a smile, and if it's a maximum, a is going to be negative, which is a frown. So remember, a maximum is going to be like the top, and a minimum is going to be like the bottom. And then we're also going to move into domain and range. And this will pull back to our exponentials a little bit, kind of where that tail was and things that are above and things that are below. Domain is going to be all real numbers again, unless it's a word problem. So that part is pretty much the same. And we do have a few more formulas, but once we have a graph, then actually figuring out your range is really not super complex. Okay, so let's keep that formula sheet handy. And let's go ahead and identify all of our pieces, all of our characteristics of our quadratic from this picture, okay? So the first thing we want to find are our roots. So those are pretty easy. We see these right here. Those are our roots. So the first one is negative 4 comma 0, and the second one is 2 comma 0. Now the y-intercept, that's one of our new ones. That is where it's crossing the y-axis. And as an ordered pair, that is going to be 0 and then the number. Okay, so in this case, it's 0, negative 8. Our axis of symmetry, okay, and our vertex kind of go together. So let's work on our vertex first. So the vertex is the point where the parabola turns around. Okay, so in this case, our vertex is right here. And that ordered pair is negative 1, negative 9. Negative 1, negative 9. Okay, so I want to come over here to the table, and I want you to look at our numbers. Okay, look at your numbers. So do you see a 7, a 7, a 0, a 0, a -5, a -5? See how those numbers are the same? So it keeps coming down. They're exactly the same until I get to this number right here. And that's where it turns around. Okay, this is the vertex. That's the vertex. And when I see these matching numbers, this is the symmetry. Okay, that's the symmetry. That is what that tells me that I have a parabola, because if there's one on the left-hand side that has a value of 7, there's got to be one on the right-hand side that has a value of 7. It has to have a matching pair. So if there's one over here, there's got to be one over here. Okay, so the axis of symmetry is an equation, and that is an undefined line. So that means it's going to be x equals, and it's x equals whatever point it's crossing. Well, it's crossing at -1. So you'll see that these two numbers are exactly the same. All right, so is this a maximum or a minimum? Well, since this actually has a bottom, I'm going to go ahead and draw a line through here. Has a bottom. This is going to be a minimum because it has a bottom. All right. And from there, we control our domain and range pretty easily. Domain is all real numbers. It's not a word problem. Okay. So it's going to be every x, every y, or every x positive and negative. The range is going to be controlled just like our quadratic. So I see that my minimum is -9. Okay. That is where I see that I drew that line. It matches the y value of my vertex. Okay. And I also see that I'm going up from there. So I know that I am greater than or equal to -9, and it's going to be the real numbers greater than or equal to -9. Okay. Because it's everything bigger than -9. I'm going up from there. So those are all the characteristics that we're going to be looking at. So when we graph today, we're going to be graphing the roots, our axis, our y-intercept, and our vertex. Those are all the things we're going to be finding, plus our domain and range. All right, so just to make sure that we're good and we understand our pieces. So let's kind of talk about maximums and minimums here. So the vertex controls whether or not we have a maximum or minimum, and that is controlled by A, okay? That is controlled by our A value. So if A is positive, I'm going to have a minimum because it's going to look like this. So A is positive. If A is negative, then I have a frown, which is going down. So we need to remember that a minimum is going to be the bottom, and the maximum is going to be a top, or the biggest number, okay? So minimum is smallest number, and the top is the biggest number. And we also have to remember what this graph is called. So this graph is called a parabola, okay? It's called a parabola. And looks like kind of a strange word, but it's a math word, and it's just the shape of the graph, okay? All right, here we go. Let's go ahead and work through this problem. We're going to go the entire way. We're going to start by finding the roots, and then we're going to move into our vertex, our y-intercept, our axis, and sketch all of our pieces, okay? So let's go ahead and factor this one, and I do believe this one factors. So let's use our x method here. So we have 30 and -13. So that's a -10 and a -3. So if I use my box, I have a 5x squared plus 6, a -10x, and a -3x. So there's a -3 and a 5, and an x, and a 2. Okay, so I have 5x minus 3, and I have x plus 2. Okay, so to be able to set those equal to 0, I need to move my 3. 5x equals 3. X is going to equal 3 over 5, which is 0.6. Move my 2. x is equal to -2. So far, I have a root at -2 comma 0, and I have a root at 0.6 comma 0. Okay, so far so good. All right, let's go ahead and continue here, and we'll add to our picture in a little bit. So when we find the vertex, okay, we're finding the vertex, we have to make use of -b over 2a comma -b squared over 4a plus c. We have to make sure and use that whole formula, okay? So the x part is the -b over 2a. The y value is the -b squared over 4a plus c. And we have to really be careful that we don't lose this negative and that c, okay? So in this case, a is 5, b is -13, and c is 6. So let's go ahead and substitute in. So -13 over 2 times 5. Okay, so I have the negative of -13 and 2 over 5. So that's going to give me 13 over 10, which is going to give me a 1.3. Okay, that's going to give me a 1.3. I just realized that we have a sign issue. So I'm going to go back here. We need to go back and fix this. So I lost a negative right here. So that is not a positive. That is a negative. So we need to change this. Okay, so now we have a point at 2 and a point at 0.6. There we go. Okay, I was going to say that's not working out right. So let's fix that real quick. And let's keep going here. So we have an x value of 1.3. So that is our first point. Now, to figure out the y value, remember I have to square and 4 times a and then plus my last number. So c is 6. And I have a -13 and a 5. Okay, so the one thing I need to realize is that this value is always going to be negative. Okay, so 13 squared is 169. The negative of that is -169. So I have -169 divided by 20 plus 6. So let's go ahead and get our calculator up here. Let's clear all this stuff out. And we have -169 divided by 20 plus 6. That gives me -2.5. So -2.5. Okay, so let's go backwards to our graph here. 1.3, -2.5. So our vertex is 1.3, -2.5. Now, one of the reasons why I knew we were having an issue was because I was coming up with an x value of 1.3. So that's here in the middle. And what that tells me is if I have a vertex that's running and it's not between the two roots I came up with, then my roots are wrong. So that told me I must have lost a sign. So the nice part is you can kind of check yourself as you're moving forward here to make sure that everything kind of lines up. So far, I've got my roots now in the right spot, and -2.5, so negative or positive 1.3, -2.5 is going to roll me kind of down here. So there's my vertex. All right, now let's keep going. Let's do our y-intercept because our y-intercept is easy. That is 0, comma c. So our c value is 6. So my intercept is going to be 0, 6. So if I flip back over to my graph, 0, 6 is there. Okay, 0, 6 is there. And eventually I'm going to see that there's going to be one matching point on the other side. But that's less of an issue for us at this point because it's mostly just the y-intercept you have to have. All right, so our next piece is our axis of symmetry. Okay, so the axis of symmetry is always in the form of x equals a number because it's an equation. It goes through the x value of the vertex. Okay, so you'll notice this is exactly the same as this. So once I have my vertex, I actually have my answer. The axis has to be x equals 1.3. Okay, it's 1.3 because it goes through the point 1.3, negative 2.5. It has to. So once I draw my axis, and remember your axis of symmetry, x equals 1.3, that is a dashed line. Okay, it's a dashed line coming right through the middle of my shape here, of my parabola. And then I'm going to go ahead and I see that this one, there's a point here. I can make a matching point there. And I can go ahead and sketch my parabola. So I know exactly how far it went down. I know where it turned around and came back up. Okay, so while we're looking at this on this slide, let's go ahead and determine our domain and range. So this is my bottom. Okay, there's my bottom. So everything is above that. So that value of where it's crossing is negative 2.5. That's where, or negative 2 point, yeah, negative 2.5. That's where it's crossing. It's this number. Okay, it's this number. So that's going to help us on our domain and range. Okay, so here's my graph. Here's my graph. This is kind of what it looks like when we get it sketched. Okay, so we had our x-intercepts here, and our y-intercept was there. So there was our 0, 6. It had 2 roots. Okay, and this was negative 2.5 because that vertex was 1.3 comma negative 2.5. That's that ordered pair. That's this point right here. Okay, and we know our domain is going to be all real numbers because it's not a word problem. And our range is going to be greater than or equal to because it's going up. And my bottom is negative 2.5. Okay. Now let's take a look at the table that kind of goes here. So this one, here's one of the ways I know that my answers are good or close. Okay. They're in the vicinity of where they should be. So I see that I have numbers that do not duplicate. Okay, I see numbers that do not duplicate. And the reason that I see that is because since I am looking at what's happening, I can tell kind of where the bottom should be approximately. So I see that these numbers come down 52, 24, 6, negative 2, and then it goes to 0. So right in here is where I should be finding my vertex. My vertex should be right in this area because this is going down and then it starts going back up. So that kind of helps me understand that this has to be right because I ended up at like 1.3. So I have to be between 1 and 2 for my vertex. And I need to be a little bit more than, between 0 and 6 or 0 and around negative 2 to make sure that I'm actually coming up with that bottom piece, okay? So not always will you be able to see the duplication or the symmetry, okay? Because everything's, there are some decimals in there, so we're not going to be able to see the exact location of our intercept always, or our vertex. Okay, let's take a look at this one and see if we can figure out our domain and range and see if we can see where things are turning around. So let's find our pieces. So how many roots do we have? Well, I see 2. Okay, there's definitely 2 roots. My y-intercept, that one's pretty easy. That is 0, 5. My x-intercepts, I don't really know where they are. This looks like it might be negative 3.5 and maybe 1.5, but I'm not totally sure. Okay. I do know that this is a maximum. So since it's a maximum, it has to be going down. So that does help me with my problem here. So let's take a look at this one. I see that I have a lot of symmetry here. The negative 10s, the negative 3s, the 2s, the 5s, and right here is where the numbers turn around. So this is actually my vertex. Okay, so negative 1, 6 is my vertex. That's important because that tells me that my range is going to be less than or equal to that 6. Okay, and since I actually know what my vertex is, I can actually sketch in my axis. And the axis is going to be x equals negative 1 because it has to match that number. Okay, it has to match that number. And it's a frown because a is negative. All right, let's see if we can do this one and see what's happening on this one. So do I have any roots this time? Yeah, no, I don't have any roots. So that's out. If I take a look at this, do you see your vertex in your table? Well, hopefully you see that you have duplicate numbers and you see that this right here is the turnaround, okay? So my vertex is 1, 4. So if I draw a line, I see that this is going the opposite direction. That is now a minimum. So I am going above that. Okay, so domain is real numbers, range is greater than or equal to, and where am I? I'm at 4. Okay, I'm at 4. It's always going to be the y value of the vertex. Okay, what about this one? Does it have any x-intercepts? It only has 1. And that value is 5, 0. It's right here. Now notice how this is also my vertex. Okay, it's also my vertex. So if I look at this one, I don't see where I have a vertex, but I see the numbers are going down, and then I'm going to assume that they could be coming back up because this does swing back around. So my domain is still real numbers. And what happens on this one is I know that I'm going up above the x-axis. It would be real numbers greater than or equal to 0. Real numbers greater than or equal to 0 would be my range. Okay, so you're going to be working on finding your pieces of your quadratic today using all your formulas. Okay, using all your formulas and then domain and range. So go ahead and get started. Reach out to us if you're struggling. We will work some more tomorrow on this. So if you're struggling, then perhaps you want to just move on to tomorrow's video and watch that a little bit to kind of get yourself going.